Hello and welcome to a ramble with me. The trig will not leave me alone. The trig refuses to leave me alone. Let's do the trig. We're doing the department's May 2022 paper 2. Question 8. Figure 1, figure 1 shows a ramp leading to the entrance of a building. B, C, and D lie on the same horizontal plane. Okay, so like the floor. The perpendicular height AC of the ramp is 0.5 meters and the angle of elevation from B to A is 15 degrees. The entrance of the building AE is 0.915 meters wide. Okay, we're not talking about figure 2 yet, so let's just focus on figure 1. So the question says calculate the length of AB. Okay, so if we just extract what's going on that side of the world, this is ACB. We've been told that this is 15. That's a right angle. We've been told that this is 0.5 meters. And we need to work out the length of AB. So this is a SOH TOA candidate. We've got this angle, the side opposite to it, and then the hypotenuse. So we're going to use sine. Sine of 15 degrees is equal to opposite over hypotenuse. So I'm just going to say that is AB sine 15 is equal to 0.5, and so AB is equal to 0.5 divided by sine 15, which is going to give us approximately we'll just take 1.93 meters. But we will store this in case we need to use it. Okay, right. So that is our answer for AB. Just going to fill it in there. One, oh, probably be better served using my fancy little tool. Come along, fancy little tool. Uh, 1.93 meters. Okay, and now the wonders of science. We shall duplicate you and take you to the next page. Okay, right. So the next question says, figure 2 shows the top view of the ramp. The area of the top of the ramp is divided into 3 triangles as shown in the diagram. So this guy, and that guy. And we know the length of AB, which is 1.93. Fantastic. If BAE is equal to 120 degrees, and we're also given this 75 degrees, I'm not sure if we can use it, or Anja. We're also, they indicate that these are equal. So guys, can we use this or not? Can we use it or not? Anyway, let's see. Calculate the length of BE. This we were explicitly told. So like I said, we know that this is 1.93 meters. And we're trying to work out the length of BE. We have an angle and the two sides flanking it. So this is a candidate for cosine rule. Remember, two sides and the included angle, that is a cosine problem. So I'm just going to quickly label my sides. BE is little a, AE is little b, and AB is little e. Right, so the cosine rule says, the one we want, a squared is equal to b squared plus e squared minus 2be cos of a. Right, so be squared, in other words, is equal to 0.915 squared plus That answer that we got was actually 1,9 what? Oops. Let me just, oh no, sorry for the empty input. 1,93 blah blah blah. I just wanted to remember if we had rounded it off or not. So this is 1,93 what squared minus 2 times 0,915 times 1,93 blah blah blah. Okay, times cos of A, which is 120 degrees. So that is going to be, we can just put this all in. I was tempted to try and do it manually, but I'm like, why would I do that? I was tempted to do it manually because cos 120, you know, special angle 180 minus 60, that means it's minus cos 60, and cos of 60 is so beautifully a half. But what about all the other weird numbers in this calculation, huh? What about that? Anyway, so we're aborting that mission. Minus 2 times 0.915 times that number that we stored times cos of 120. Let's see what we got. So we get 6,336 blah blah blah, and then the square root of that is 2,52 meters approximately. I'm going to store that too in case we need it. Oh, calculator's getting busy. It is getting busy. My goodness. Right. So now we know the size, the length of BE. I will now fill that in. Using my special tool, once again, any opportunity I get to use this tool, best believe I will use it. So this is 2,52 meters. I also now have the urge to clean this up now. Okay? Now that you're here, everything is different. Everything's so different, Lord. No, I'm not the same. Okay, I'm putting this on. Anyway, so now let us duplicate the thing and take it to the last page. Okay, so the last question says, calculate the area of BFD if the angle BFD, now we're told, is 75 degrees, BF is equal to FD, so we've got an isosceles triangle here, and BF is 5/7 of BE. Okay, so nice simple, very, what do you call this? Oh, a nice simple fraction calculation, you know. Oh my goodness, I am just trying to move this thing. Just the number. Just the number. Can I do that? Okay, I just want to move this up, make it more central here so that we can see that 2,52 is the whole of BE, not just BF. Okay, so BF, oh, that is some very skinny writing, is equal to 5/7 of BE, which we calculated before to be 2,5, some number that I forgot. Oh, calculator working overtime. Okay, which is roughly 1. Yeah, we're not going to use roughly at this point. We don't need the rounded number. It's not the final answer yet. Okay, so I'm going to store you true, just in case. Just in case I'm probably going to need it. So yes, good idea to store it. Wait, did I store it? You know, this bombastic number situation. We don't know sometimes what's going on. Okay, so now we know the length of, I'm just calculating with no direction. How am I going to find the area? We're using the area rule, which also relies on two sides and an included angle. So by knowing the length of BF, we know the length of FD, and we're given this angle. So nice and easy peasy lemon squeezy. And so we can say that FD is also equal to 179 what, because we were told that it's the same. Sorry, can make this explicit. We were given that BF is the same as FD. Okay, so now we can work out the area. Area of triangle BFG is equal to a half of these two sides multiplied together times sine the included angle. Oh, we are forcing matters, guys. Come on. Come on now. Okay. So times by sine of 75 degrees. So let us calculate that. A half times, and we could just say c squared, and then sine of 75, which gives us drum roll. 1,56 square meters is the area of that little triangle just chilling there, living its best life. Let us see what the memo believes. So for our first answer, we do indeed get 1,93. They use the sign of SOH CAH TOA. Perfect. For the second one, we get 2,52 using the cosine rule. Also perfect. And for the last one, we get 1,56 square meters as our area, also using same approach. Wonderful, marvelous, glorious. Thank you so much for coming along for this ride, and catch you soon. Hopefully, I am going to push through and try and finish this paper tonight. So 3 questions to go. Let's read.